Hi, I'm Pushkar and I'm discussing KVPY 2020 essay part 1 paper chemistry. Here's a question which belongs to atomic structure. A certain metal has a work function of 2 electron volts. It is irradiated first with 1 watt of 600 nanometers light and later with 1 watt of 800 nanometers light. Among the following, the correct statements are Planck constant is given 6.626 and speed of light is also given. Both colors of light give rise to the same number of photoelectrons. 600 nanometer light gives rise to less energetic photoelectrons than 800 nanometers, and 400 nanometer light leads to more photoelectron, and 800 nanometer light leads to more photoelectron. So, having considered these options, let's first see what is the theory. The work function is 2 electron volt. First of all, let's find out what is the energy of a single photon. Energy of a single photon. That's quite important because that is going to give us the idea that whether the photon is able to knock out the electron from the metal or not. To get this, what we need to do, we need to find out the hc by lambda. hc by lambda, and this is equals to 6.625 into 10 to the power minus 34 into 3 into 10 to the power 8 meters per second, and divided by this lambda, which is equal to 400 and 800 nanometers respectively. So we'll have to do this. Obviously, we are going to get this energy in terms of joules, and if we can convert it into electron volts by dividing it by 1.602, okay, so there is a much more cleaner method of doing this. And what is that? We can use this formula, E into lambda is equals to 1240 electron volt nanometer. By using this formula, which obviously not a rocket science, will simply come from solving this equation and converting this joules into electron volt, and also converting this nanometers into the meters. Sorry, and converting this meters into what? Nanometers. So if we have this formula, we can get straight away the energy of a single photon in terms of what? Electron volt. So let's find out. So E into lambda is equals to 1240 approximately nanometer electron volt. So if the lambda is equals to 400 electron volt, this gives us energy of the single photon is equals to 1240 divided by 400. 10 cancelled, and this is 12.4 divided by 4, which is equal to 12, and this is 3.1 electron volt. So energy of a single photon is 3.1 electron volt in case of 400 electron volt. And if lambda is equals to 800 electron volts, then you are going to get E is equals to 1240 divided by 800, and that is going to be half of this, and that is equals to 1.55 electron volt. So obviously this 1.55 electron volt is less than the work function, which is 2 electron volt. So that means 800 nanometers, and this is 400 nanometers. So 800 nanometers photon is not going to be able to knock out the electron. So that's a straightforward result. Now, after looking at this result, both colors of light give rise to the same number of electrons. No, one of them will not give at all, will not give the electrons at all. Second, 400 nanometer light gives rise to less energetic photoelectrons. It's absurd because 400 nanometer light is of having more energy. It's absurd. 400 nanometer light leads to more photoelectron. Of course, it is correct. And 800 nanometer light leads to more photoelectrons. Wrong. And one more thing, even this statement is not absolutely correct because 400 nanometer light leads to more photoelectron. Instead of this, it should be only 400 nanometer light will give photoelectron. So there is something fishy in this option. So that is why we need to solve it fully. Otherwise, you could have done it straightforward by looking at the options. Okay. No need to solve it, but We've solved it just to show what will be the systematic approach of solving the problem. So I hope that you understand this problem and stay tuned for next question. Thanks for watching.